All right, everybody, we just got about 1 minute to go, and then we're going to kick off the webinar today on when seconds matter. All right, hi, everybody. My name is Peter Ashley. I work for Applied Information, and today I am broadcasting live from the IATL, the Infrastructure Automotive Technology Laboratory. And today we're going to be talking about when seconds matter, the emergency vehicle preemption system. So I'm going to go through a couple of different things today. First of all, we're going to take a little walk around. I'm going to show you some of the equipment over here, and you're going to see exactly the actual units that actually do the emergency vehicle preemption and the units that go in the cabinets. And then I'm going to jump into a presentation style where I'm going to go through a bunch of different things. So forgive me, you're going to see this thing move around a bit. So as I basically walk around, I'm in the IATL at the moment. And we're going to walk through down here, and we're going to see some of the equipment that's used. And I'm going to point the camera, so it's going to feel a little bit weird, but we've got the cabinet units. So this is a traffic signal cabinet. For any of you that haven't seen one of these, this is a NEMA style cabinet here. And as I go in a little close over here, you'll see under the Siemens controller is the AI 08502 unit, which is doing the emergency vehicle preemption. And over here is a Coltrane style 332 cabinet. And there's the unit as well. And what's interesting with this, we can actually go look at the back of the unit over here just to give a bit of an idea. So there's a wiring harness over here that's made by a backplate that's made by Temple on their cabinets, and it wires everything directly into the cabinet so that you can do emergency vehicle preemption. Over here, well, just to show you a bit of the IATL, we've got testing equipment for traffic signals, pedestrian crossings, railroad crossings, school zones, and then we also have traffic signal controllers from every manufacturer in the US. So we've got where we can test with the Interlight controllers, Peak, Nasdaq controllers, and then on this side we've got Siemens, Conlight controllers, the Conlight EOS, and over here we've got Walt Townsend, who's the brains behind emergency vehicle preemption. So he actually keeps everything actually running and working. And also this is important, there's, if you have a look at the top here, there's a cellular and GPS antenna, and on the other side of the cabinet is a 900 megahertz radio antenna, and that's providing the communication for the direct communication over 900 megahertz, and this is providing the GPS and cellular communication. And then over here, we'll see the vehicle unit, and this is a vehicle unit that has a test box on it. So normally speaking, we would just have this unit in an emergency vehicle, and it's wired directly into the left turn, right turn, emergency lights, and so on. And if you have a look down here, you'll actually see the different labels for, this is a test box that allows us to test when the key's on, when the emergency lights are on, when the left turn is active, right turn, and the disable switch is on as well. So it gives you a great way of testing these systems when you put it out there. Very important for the traffic department to have one of these units so that they're able to test the emergency vehicle preemption and do runs. So we use that a lot with that test box when we're going to commission a system. As you're running through, check that the correct preempt is happening as you're driving through all of these intersections. So I just wanted to show you a little bit of the actual physical hardware that goes into all of these different devices, because seeing it, and there's different form factors of the units as well for different style of cabinets. But that gives you an idea. There's always a unit in the traffic signal cabinet, and there's always a unit in the emergency vehicle. So right now, I'm going to basically share my screen over here. So you'll see my video will probably go a little bit smaller. And you should be able to see my screen. And I'm going to go jump into a short presentation, and then we're going to jump into some questions at the end of it. So a little bit of a background, Applied Information, we now deployed in over 590 cities. We've got over 17,000 devices deployed in the field. Every single one of those has got a cellular modem, so it means it's always connected. And we're about 75 employees within Applied Information. And we go to market through distribution. So we have distributors who are always going to be providing our services and doing a lot of the installs with some support from us. So what are the core product lines that we have? So we very involved in connected pedestrian safety. That's school zones, pedestrian crossings, driver feedback signs. And then we do connected traffic signal controllers. So that's obviously the traffic controllers providing remote communication to each of the traffic signal controllers, as well as providing the emergency vehicle preemption. So the unit that does a traffic signal controller that does remote communication also does emergency vehicle preemption. So when I talk about these products, you'll see how they all line up together very nicely. We do connected vehicles as well with all of our products. So whether it's a school beacon, a traffic signal controller, preemption emergency vehicle, it all connects back up to our connected vehicle system, which I'm going to explain a little bit towards the end to just give you a bit more of a background of that system. So emergency vehicle preemption, how do we do this? So what we're doing is, and I'm not going to explain preemption as a concept that, in terms of, as we put in as the emergency vehicle comes, it puts in a preemption call that then requests the traffic controller to go green. What our system does is it uses 900 megahertz radio and cellular communication with the GPS position of the vehicle. What's important with that is we have redundant communications. We're not just relying on one or the other, because when you're in an emergency situation, you should have redundancy. What happens if that 900 megahertz radio doesn't work? What happens if the cell network doesn't work? We always have a redundant backup. And we also report back any failures. The units are very easy to install. It probably takes an hour and a half, 2 hours, 3 hours for a traffic signal, depending on how experienced you are, and around about the same time in an emergency vehicle, depending on who's actually installing it. As I said earlier, all of this technology works together with our connected vehicle technology. So alerting where the emergency vehicles are directly to citizens. So this is a great diagram. I'm going to try to get my mouse over here. So what's important is we're tracking the vehicle's GPS position, we're tracking his heading, and we're sending out messages to the traffic signal cabinets of where that vehicle is and where he's approaching. We integrate to the emergency lights, so we only provide emergency vehicle preemption if the lights are on. And we hook into the left turn indicator, right turn indicator, and emergency brake to ensure that we can track exactly where that vehicle's going. We are always sending out the messages over 900 megahertz radio and cellular communication at the same time. So the way that works is if the traffic signal controller receives a message from the emergency vehicle, it will either receive it first from cellular or through radio, and it'll just process whichever one comes first. All of our messages are timestamped. Generally speaking, about 99% of all of our emergency vehicle calls first come through cellular, because the cellular works a much further away, distance away from the traffic signal. Also, at the same time, the traffic signals are monitored at all times by the GLANCE system of if there's any failures or anything like that. But what the really cool thing is when you're doing over the cellular system is we talking to this signal here, the next one downstream, and the next one downstream. We can connecting to all of them, and we're saying this emergency vehicle is approaching. Start changing your signal to green now, so we can flush out traffic ahead. And because we hooked up to the left turn indicator and the right turn indicator, we can actually say, all right, we're turning left here. This intersection on the left, start preparing to go green right now before the vehicles even turn left, because we can see he's got his left turn indicator on. So it's adapting all of the different intersections at all times so that we can ensure that you're always getting a preemption. Now, that requires us to have a really great rules engine that allows you to configure all these different rules to make things work better. And that's why we work together with the traffic department and the fire department to create these rules. So when we first start a system, we create the rules for you as best of our knowledge. And then when we come and we do commissioning and all the rest, we sit down and we look at it, we drive the routes. And a driver will say, well, you know, at this time of day, we get a lot of traffic back up along here, all the way up to this intersection. So then what we do is we create a special rule that will preempt 3 intersections in advance so that we can get those trucks out of the stations. So there's all sorts of great things that we can do, and utilizing that cellular communication makes everything possible. Because we can communicate so much further ahead. We can communicate around the corner, over a hill, around the buildings, so that we can get preemption working. This is a quick little view of what a map view would look like. This is in Odessa, Texas, where they've got a number of emergency vehicles, and they've got, you know, their signals here, and they've expanded the system. I think this is a bit of an older screenshot. But they've got, you know, their vehicles are running up and down there all the time. It's using Google Maps, so very easy to use. And, you know, you can see a list of all the intersections over here as well. This is a much larger system where the city of Baton Rouge has got 460 intersections and 80 vehicles. So they've got every one of their intersections connected. And, you know, they obviously have a large number of emergency vehicle trips, but they've got, you know, all of these intersections. And what's great with this is they can look at their vehicles or their intersections, or you can see over here that they've also even got school zones that they're deploying. And you'll see these little lines on the map here. I'm going to see if I can spend some time just jumping into one of the live systems that you'll see what these things are, because each one of these lines is a trail that the emergency vehicle has taken. So what's great with the system as well, you'll see over here, we've got playback as well. And we can go back and play back any event that an emergency vehicle had. So what's great with that is, let's say you had an emergency vehicle event that you were responding to, you know, an emergency, and you wanted to see, well, what route did that driver take during that day? You can play back at any time where that person went, what route he took, and how he got to that situation. So you can do multiple vehicles at the same time, so you can see how they're all coming towards that event, to see potentially how do you optimize the route of those vehicles. And there's different color codings for the map. Blue, which is idle, orange, which is the in service, red, which is in service with the left turn, and yellow, which is in service with the right turn activated. Now, what I really like, and I think the power of the system, is all of the data that we're collecting and how we can provide insights to that. So what we do is we track every emergency vehicle trip, and we can look at, here the vehicles for 18 vehicles that they had. They did 3,700 trips that there was no emergencies. They did 900 emergency vehicle trips that were within their city limits, and 300 emergency vehicle trips that were out of their city limits. What do I mean by in the city limits? So Odessa Fire Department does a lot of mutual aid calls, and they were finding that their ISO ratings, which is really important for the insurance organizations, were showing quite high numbers, and they realized it's because they do a lot of trips that are mutual aid calls, but then everything within the city got a bad reputation because they thought their average response times were very high. So what we do is we look at all of the emergency vehicle trips within the city, and then all the emergency vehicle trips outside of the city. And you'll see here that their average response time is 3 minutes and 36 seconds. That's really good for emergency vehicle trips within the city. And then the emergency vehicle trips where they're doing mutual aid, where they're helping out the city next door, are 7 minutes because they're traveling a lot further. You'll see the average distance that they travel from the fire station to an emergency situation is 2 miles. But when they're doing the mutual aid, it's 5.4 miles. So all of that information is calculated for them on a monthly basis so that they can go out and look at how is everything working within our city on a grand scale. They can also look at each individual vehicle, or they can look at the fleet as a whole. And you can see on their fleet as a whole, the 90th percentile trips, which is the 10% of the furthest trips that you do within their city limits, is just over 5 minutes. So that's when the fire department's got to go really far, the limit of their distance that they normally go on the city limit edges, or the distance away from the fire building. So it's providing great insight because, do I need to build more fire stations? Do I need, because the longest distances are far away? And when you look at the data, at least from Odessa, they're doing really, really well. They're getting to the citizens in need really quickly within 3.5 minutes, which is really good on average. And their 90th percentiles just on 5 minutes, which is also really good. This is also a pretty cool view, which is giving you a view of where are these emergency vehicle trips? When are they happening? So these are the hotspot times in a heat map on, this is the day of the month, this is the time during the day, in other words, each hour, and you can see that generally the emergency vehicle trips are happening between 7 a.m. and 8 p.m., but they still have quite a lot happening at 10 o'clock and all the rest. They don't have very much happening at 3 a.m. in the morning, but this gives you an idea that, wow, this week was really busy over here, where they did 20 emergency vehicle trips on Friday at 9 a.m. in the morning. So this is giving them insights of how should they be staffing their stations. When are most of the emergency trips happening? And then they can go down into detail on each of the different engines or EMT vehicles or whatever vehicle they have, and look at, these are emergency vehicle trips that they're doing. What was the start location, the end location, the total distance, the average speed, so they can go through and look at anything that jumps out at them. So everything's tracked, everything's recorded, and it provides these reports automated. They don't even have to go to our system to download them. It'll just email the report once a month, once a week, however often they want to receive it. This report is going into a little bit more for the traffic engineer. So we track every single emergency vehicle preemption call to see, is the system working correctly? And so this is engine number 8 coming through Baton Rouge intersection, P Airline and Home Depot. And you'll see that this came in, this is starting at 0 seconds when it came in. And you'll see that the ETA of the vehicle was 57 seconds when it first triggered a preemption at 1,500 feet away. And he was driving at 19 miles an hour. And phase 4 was active at that moment. 3 seconds, this is 3 seconds later, and then you'll see 10 seconds later is when the greens changed to 2 and 5 being active. So it took, the clearance time for this intersection was around about 10 seconds. Okay, and then you'll see that 26 seconds later, that vehicle drove through the intersection. Well, what's really cool to see here, when he first entered, it was 57 seconds ETA because his speed was quite slow. So there was probably traffic ahead of him. And then you'll see his speed increases again here. Whereas when he went through, when he was 10 seconds away, he was already driving 29 miles an hour. And so that whole event took 26 seconds. And over here, he's heading away from the intersection, and there was no preempt active at this stage. So it's really, really cool to see all of that information, to see exactly what's happening at that intersection. So we can see whether or not we need to change the, in other words, the times that we start the preemption and so on. All of this information is available to the, to generally the traffic department that knows how to read this, or ourselves. And what's great with this is we can come in and we can say to the, the fire department, where they report back and say, well, that intersection wasn't really working the best at that location. And we can look at it and we can say, well, the clearance time, we put in the preemption call, and the clearance time took 26 seconds. Oh my goodness. Well, we've got really long PED phases on these intersections. So let's increase our ETA to 60 seconds. And we've had to do that in certain cities. In Atlanta, for instance, they had a PED clearance time of 20-something seconds. So we had to do a preemption ETA of over 45 seconds. All right, well, that's fine. But then you got to remember that that has to, if they've got long PED clearance times, you need to have cellular, because you need that long distance away from those intersections. So this is a little bit of information on Marietta. They did a lot of studies on their system, and they were seeing on an average emergency run, they were crossing about 6 intersections. They were shaving off about 10 to 12 seconds per intersection using this system. So they were saving round about 60 seconds, and they were reducing their travel times. They said that, it became safer because everybody else is brought to a stop. They're not having to worry about all these cars cutting and cross of them because they don't have a negative intersection. Their signal's not red. They don't have to go through their standard operating procedures of stopping, gaining control of that intersection, and then going through it. What's really cool with Marietta is their story. They saved around about 60 seconds, but that didn't stop them. They continued to improve by looking at those locations where they could improve. So the fire department said, we struggled to get out of this intersection because 3 intersections ahead, we have problems. Okay, so then we look at the rules and we change the rules a bit. They now doing 1.5 minutes of savings per emergency run. So they've constantly improved. And the fire chief says it's a constant improvement. We continue to look at it, work on it, because all of a sudden someone does some streetscaping and puts in a median. and now they got to change their rules a little bit. Okay. Traffic signal timings change. Okay. So we constantly working. This is not a system that you put in and, you know, yes, you can just leave it to run and it'll work great. But what's great with this is you can continue to evolve with it and improve. And no matter what happens within the city, you can continue to do more to make the system work better for you. And obviously this is, you know, a video that I'm going to play. I hope it plays through the GoToMeeting. Otherwise, Jessica will send out a link of the video. This is the importance of why seconds count.
You're late.
By 5 minutes, Dad. Come on.
Well, that's 5 minutes I could have spent with my grandchildren. Get up here, boy. Hi. And my favorite grandchildren. This is amazing.
Come on, Grandpa, it's my turn.
Oh, no, just 2 minutes, kid. Come on. Wait 30 seconds to try it again, okay? What did I tell you?
Wait for it.
Get ready for green.
Get out of here.
Pretty cool, huh?
5, 4, 3, 2, 1.
Grandpa, are you feeling okay?
24, you're responding priority to 828 Claiborne Avenue, 79-year-old male having difficulty breathing.
Yeah, we're gonna get you checked out.
Grandpa, are you okay?
Green to the scene every time. That never gets old.
Sir, you're going to be all right.
We're going to take you to the hospital to get checked out, just to be safe.
By giving emergency vehicles green lights, travel safely saves first responders 11 seconds per traffic light. We know seconds count. That's why we're paving the way to a safer, more connected future. Find out how you can make your community safer and travel safely.
And I know that, you know, everybody's been in one of those situations, and it is really important. These systems are really important. Getting people to, getting the emergency responders to scene quicker makes all the difference. And that's why I'm so proud of what we're doing here and the constant improvement that we're seeking all the time, which is, you know, hugely important. So, you know, very proud of what our company's been doing on emergency vehicle preemption, and it's an exciting thing, and you know, constantly working on making these systems better. I'm going to shift over a little bit to the traffic cabinet side a little bit. So, you know, that was heavily focused on what is the fire department getting out of it. But so we've seen now that's what the fire department's getting out of it. But what is the traffic department getting out of it? And it's kind of the first emergency vehicle preemption system where both the fire department gets a massive benefit, but the traffic department also gets a huge benefit because they're getting remote connectivity to the cabinets and a whole bunch of different features. That it's one of those great things that we're actually bringing the traffic department and the fire department together for the first time. Because generally, you know, when you did preemption in the past, the optical solutions and all the rest, traffic department had to maintain these, and you know, it's just a maintenance item for them. They don't see any benefit. Whereas now, they actually get a massive benefit out of the cabinet units. So we're going to jump into some of the features there. So for the four main things that the AI 500-085 unit does is it does remote cabinet monitoring. So it's monitoring the AC voltage, cabinet flash, your fan, all of those kinds of different devices, temperature and humidity within your cabinets, to tell you if you've got a cabinet problem, BBS batteries, those kinds of things. The second thing that it does is it provides pass-through communication. That's critical. We've got a lot of cities, especially the smaller cities, that don't have a lot of fiber. And this now provides communication directly to their traffic signal controller via remote front panel, or to their central system. If they've got a central system, Tactics or Centrax or whatever system you have, you can now get connectivity to all of your traffic signal cabinets through the cellular communications. The third thing that it does, which we've been talking about, is emergency vehicle preemption and bus priority. So everything that I've talked about in emergency vehicle preemption is also available in bus priority. Works a little bit differently. We put in a priority core instead of a preemption core. And we generally do it a lot further away so we can keep the traffic controllers in coordination. But both of those types of technologies are very similar to each other. And then the fourth thing that it does is the travel safely aspect. You might have seen a little snippet in that last video where we were showing the get ready for green and emergency vehicle approaching from the front. So what's great with that is it connects the citizens to the traffic systems and makes them feel part of it. It also gives us more detector calls as well, which I'll get into in a little bit. So some of the things we're monitoring: AC voltage, preemption status, time synchronization, battery status, that's your BBS batteries, signal in flash, door status, fan status, temperature and humidity. And you'll see here, we also support video streaming. So if you've got a iTerrace camera, or you've got a Access PTZ, or whatever type of camera you've got, I don't really care for the detectors that you've got out there, or PTZ cameras, you can get access to all of those cameras remotely through the cellular communication. And we can stream up to 4 cameras simultaneously. So cellular communication has become so great now and so fast. Everybody streams videos on Netflix and all the rest. We can now do it through these boxes as well. So it's giving the traffic department huge benefits because they can now get connectivity to every one of their intersections, and especially for smaller cities. I love to talk about Cullman, Alabama. They wouldn't have been able to deploy a system and put fiber in, and because the cost of doing that throughout their city would have been astronomical. But they put these boxes at each intersection, got remote communication to their intersections and emergency vehicle preemption, and they did it for a fraction of the cost of putting in fiber. So you're saving a huge amount of money, and the reliability of cellular is so high because it's federally mandated that these cell systems need to work 99.9% of the time. So you've got this huge benefit here. On top of that, let's say your city's got fiber network. What this device does now is it provides redundancy for your city. If your fiber gets cut, you can roll onto the cellular system and just basically get connectivity to your traffic signal cabinets as well. So there's really cool things that you can do that get you this kind of connectivity. Pass-through communication. This is critical for us because we support all of the major manufacturers. So Siemens, Econolite, McCain, Interlite, Trafficware, Peak, we support all of them and all of their central systems. So and it's all secure communications. We use VPN networks. So we actually get onto the city's VPN network. And if you're not on the VPN network, don't have to worry. We don't have to be on your VPN network. You can also access this, and you can get access to the remote front panel. So a lot of the smaller cities who don't have a central system, they get a remote front panel access that allows them to connect as if they're sitting right in front of the traffic signal controller. So great benefits for them as well. So we're utilizing the LTE communication. You know, it's 50 megabits up and down. There's lots of speed on there that keeps us going really quickly. What I also love is the data that we're pulling back. We found, and the reason why I'm showing low AC report is we found 90% of traffic signal controller failures are power failure events. Most people think their power is great, but there's a lot of power failure events when you're monitoring this all the time. And what we do is our units monitor the AC power every 10th of a second. So we can pull out brownout events, short power failure events, and also long power failure events. So you can see, these intersections over here had 2 power failure events, and it was an hour and 35 minutes for these intersections that they were down. But this gives you a quick overview, and you can also look at from month to month, what were the power failures happening, where were most of them happening, because potentially you take this to the utility and they can say, we're getting 6 power failure events at that intersection all the time. I wonder if there's something wrong there, and they can go out to that location and they can potentially fix it. Or you can use this data to say, that intersection always gives us problems. We're going to go put in a BBS, battery backup system, at that location. So it's a great way of looking at it. And you'll see actually here the different power failure events. So I can see this was on the 1st of December. It was a 14-second long power failure event. But then this one on the 8th of December happened just around midnight, just before midnight, and the power was restored at around 1 a.m. And that power failure event lasted 1 hour and 21 minutes. They had 30 power failure events totaling 12 hours of downtime for the city. You can see you almost never have that kind of downtime with a traffic signal controller. Your power failures are the things that have your most downtime events that you'll see. So that's a little bit of what we're doing inside of the traffic signal controller. What are we doing with this system with connected vehicles? So what we've done is we've created a smartphone app that runs on any smartphone. And what's great with that is it's able to actually provide connected information to the citizens of where the emergency vehicles are coming, the emergency vehicle approaching from behind, so that they can move over and stop and actually see what's actually happening and let that emergency vehicle move past them. So they get these advanced warnings, and that's, a lot of people panic when they see this massive red or yellow vehicle coming behind them and they freak out. Well, now they can actually get an alarm before they come. It also, there's over 250 million people with smartphones in their vehicles today. So we can get access to all of those people and provide this technology to them. There's a short little video over here that will show you some of the applications that we're doing on the connected vehicle side.
Meet Travel Safely, an app that helps you get where you're going safely. Travel Safely works if you're driving, walking, biking, wheeling, scooting, or skating. Get real-time audio notifications
Red light.
so you can focus on your surroundings. Get notified when you're approaching a red light or when it's time to get ready for green.
Get ready for green.
Travel Safely works with local emergency vehicles, helping them respond to calls faster. Get notified when an emergency vehicle is approaching,
Emergency vehicle front.
or when to share the road with your two-wheeled friend.
Cyclist. Vehicle approaching cyclist.
Travel Safely tells you when you're passing a school or work zone, and if you need to slow it down. So whether you're on the road or just crossing,
Pedestrian.
every time you open Travel Safely, you're helping make a better commuting experience for all of us. Together. Download the Travel Safely app today and join our community of users committed to making our roads safer.
So you can see how this is basically creating a community, and we're not just doing one type of application, we're doing all of them. So we're connecting citizens to traffic signal controllers, we're connecting the cyclists and the pedestrians to the traffic signal controllers and to the vehicles to avoid collisions. We're connecting the vehicles to the school zones to slow them down, and connecting the emergency vehicles to everybody to provide warnings that there's an emergency vehicle approaching. So it's a really interactive system that's connecting everything together. Now, you know, for the traffic signals, you saw over there, we did red light running. So when you're coming down a side road and there are trees and things like that, and someone doesn't see the signal and just blast straight through the signal, we're stopping those things from happening by saying red light ahead. So we're looking at the vehicle speed and how he's approaching that traffic signal and whether or not he's actually going to run through that traffic signal. So there's great ways of us looking at this and providing life-saving technology there. At the same time, also providing a convenience for the actual citizen, because we do get ready for green. And get ready for green is the coolest feature out there. It enunciates get ready for green just before the traffic signal is going to change, so people behind you don't honk their horn and say move it. And what's important with that is all of our systems on Travel Safely are audible first. 93% of all of our users are using the Travel Safely app in the background. They're using Waze, Google Maps, or the phones in their pocket, and providing these audible alerts to them of what's actually happening in front of them. So this is providing this life-saving technology to all the citizens within the city, and it's a free app. Anyone can download it. So a lot of the cities promote it and all the rest because it doesn't cost them anything, and they've purchased the equipment for doing emergency vehicle preemption, and they're getting all of these additional features that makes the mayor look great, and makes the everybody else within the city council look like they're actually doing something for the citizens. We do some really cool things. We can detect all the cars approaching a traffic signal and put in advanced detector calls to the traffic controllers. We work with certain camera manufacturers, and we can detect pedestrians in the crosswalks and provide an alert. If there's someone illegally crossing there and your signal's green, we can provide you an alert that there's a pedestrian in the crosswalk ahead of you. Or if you're turning right and there's a pedestrian in that crosswalk, we can provide you a warning saying there's a pedestrian on the crosswalk on the right. So there's a lot of great features that we've built into the system to try and make it just much safer, and to connect emergency vehicles to traffic signals, to the pedestrians, to the cyclists, and to the vehicles, to make everything work that much better. We're working with on the Google Play Store, Apple App Store. We actually work inside of Ford Sync 3 vehicles. We're working on Android Auto, and we're also part of the 5G Automobile Association, where we're trying to get this into every vehicle. So no matter what it is, this will be on the dash inside of the vehicle. What's really important with all of our equipment that I can't stress enough is our systems come with a connectivity and support plan, generally speaking, for 5 or 10 years. What that gives you is guaranteed cellular communication for the next 5 or 10 years. And after that 5 or 10 year period, you can just extend the connectivity and support plan contract, which is obviously a fraction of the cost of the whole system. But what it does is we guarantee cellular communication. So we've had a lot of people that we've moved from 3G to 4G and from 4G to 5G. So we know that that's coming, the 5G communication. So we guarantee cellular communication. So we will actually provide you with new chips and things like that that you can put in that utilize the new communication platforms. Also really important is our systems provide our connectivity and support includes an unlimited warranty on our hardware. So no matter what happens, lightning strikes, whatever it is, we repair or replace the unit for free. So we don't add any cost for our RMA. That's part of our connectivity and support plan. And let's say you do 5 years and then you extend it for another 5 years, that gives you another 5-year warranty. So we continue to provide the warranty and the support and the cellular upgrades as part of our system. The over-the-air software updates are also really critical because we continue to improve our systems. We don't just stay static. You don't need to take a computer out there and update software. We can do it over the air. So when we come out with new features, new functionality, that's available to you just as part of our connectivity and support. And then of course, the Glance Travel Safely application is part of the connectivity and support plan as well. So it's a great way of getting connectivity and also support for your systems and ensuring that technology is going to work for the next 10, 15 years. So we've got some customers, Quebec City, who did a 15-year connectivity and support plan. Great. So there's, it just depends on what you want to do and what budgets you have within the city of how you want to actually structure that out. I am going to slow down there and I can jump into a bunch of other things, but I know that Jessica is about to come on the line and say, Peter, you need to slow down and do some questions for everybody.
That's right. How did you know it's coming to get you? So I have Jay Jackson from MBTA. He has a couple questions for you. Jay, I'm going to unmute you here. If you don't have access to a mic, I can ask your questions for you, but let's try this way first. Jay, are you there?
Hey, I am. Can you hear me?
Yes, sir.
Yes.
Great. All right. First question I had was, how is the ETA calculated? Or is it using like a simple formula of instantaneous speed and distance, or is it more sophisticated than that?
Generally speed and distance, yes. So it depends on how you want to set it up. So generally the ETA is done on speed and distance when you've got a nice straight run up towards a traffic signal. For emergency vehicles, when you're talking about bus priority and stuff like that, we do a lot of places where we do check-in loops. We also hook into the doors in terms of whether or not the doors are open and closed. So we can do all sorts of specialized rules because depending on if you've got near side or far side stops at a traffic signal, we need to have a different type of priority call coming in. So the rules engine is really flexible in terms of how we want to set up the actual priority or preemption call.
So to kind of ask a little down that line, could you have it so that at maybe every single like 20 feet or so, as it's approaching an intersection, you could sort of know what it's likely, how many seconds it's likely to be to get to the stop bar?
Yes.
Based on like previous history or something like that?
Yeah, so generally speaking, we're using the speed of the vehicle, but we could set up check-in loops. So we also have some rules where we can actually, if you know the general aspect of when he crosses this point is 10 seconds before he gets to the signal, we can set up a call that comes in at that specific point to the traffic signal controller that's around about 10 seconds away.
Okay, yeah, so would you be able to track that so that we could improve that? So one of the issues we have is variable dwell time, especially with those near side stops. And so what I'm trying to look at and understand, and I'm kind of new with the MBTA, but I'm their TSP coordinator. It's kind of a new initiative we're trying to get right for once. I can go into that long detail, but is to get tracking of how it's happening over like time of day, day of week, and to be able to use some sort of like machine-based learning analysis, predictive analysis to get more intelligent with that.
Yes, so we've been doing that here actually in Marietta, where they've got a whole bunch of the buses going through, and we're tracking all times of days, whether or not it's improving the priority and so on. So we've got a whole bunch of sophisticated reports that we do. And what I would suggest is probably, Jay, what I do is I get one of Walt, who is actually in the lab over there. I get him on the phone with yourself, and we can walk through the types of reports that we're doing to see how we fit in. Because obviously you've got certain situations that you're looking at, and we can create different rules, and we can create the different reports that would show you the information that you would want. So in other words, to look at, because we can also look at how each individual intersection, the dwell times are changing also on the intersection as well. So what we found is the depending on time of day and the pedestrian calls that are coming through affects your dwell time of your intersection. So we can get all of those kinds of things.
Absolutely. I don't want to hijack this meeting. We can definitely set up a thing to chat online. I think that would be great. You have my email address, so I'll ask one more question. It's different though. Have you done any? I'm a little concerned. How do I ask this the best way? The get ready for green. From a safety perspective, has any research been done on that? Because that seems like that would defeat some of the all red clearance kind of safety benefits. Has any thoughts around that?
The University of Alabama has been working on it. They've been looking at it more from a factor of what's been happening at the startup since people have been using their smartphones. And they've seen, obviously, people, they, over the last 3 years, the startup times of traffic signals have decreased quite a lot. So they're seeing that it improves the startup time. But because what we do is we don't, it's round about 3 seconds before the signal changes, we provide a get ready for green. It's 3 to 4 seconds. So it's never exactly 3 seconds or exactly 4 seconds, it's 3 to 4 seconds. So there's no way of people really jumping it, because 3 to 4 seconds away, and one Mississippi, and no one actually, don't really get the jumping of the signals. But a lot of people like that because it gets people to start up quicker, and that's improving the throughput. They're seeing about a 5 to 10% improvement in throughput because they're getting about a 1 to 2 seconds increase in startup time at the traffic signals.
That's interesting. And I actually lived in Marietta when I went to Georgia Tech. So the priorities are definitely much more vehicle focused down there. Up here, we don't really care too much about the vehicles. We care about the bicyclists and the pedestrians and the, and more so, you know what I mean? I'm being just, but so thank you for answering my questions.
We're doing bicycle priority as well at Signal. So we do bicycle detection. So if it's a cyclist using the travel safety app, he can actually put in a detector code to the traffic signal. And we're actually doing some applications where we're looking at doing groups of cyclists that we can actually put in a priority call to a traffic signal when a group of cyclists arrives at the same time. So some really cool things happening at the moment in the connected vehicle space.
Yeah, absolutely. All right, well, thank you for answering my questions.
Appreciate it, Jay. We'll definitely get back to you and set up something.
Great.
Thanks, Jay. You'll be hearing from Chris probably. He's our business developer in the East. All right, so next question is going to come from Daniel Quiggins. I'm going to unmute you so you can ask your questions about DSRC and CV2X. Daniel, you are unmuted. Can you hear us?
Okay, well, I'll read it out.
For him. Yeah, it's what about DSRC or CV2X? If we already have this, can you integrate?
And the answer is yes. So we work with multiple different manufacturers of DSRC and CV2X. And obviously our devices support connecting with all of those different types of providers. So we also have a RSU that does both DSRC and CV2X simultaneously at the same time. And we also have an emergency vehicle preemption unit that can do 900 megahertz radio, cellular, DSRC, and CV2X all at the same time. So it's a different unit. It's the 06502, and that can get put into an emergency vehicle that will actually provide and then connects to emergency lights and all the other aspects behind it to provide emergency vehicle and buses with priority using DSRC, CV2X, and cellular communication.
All right, Peter, our next question comes from Cynthia. She's saying, does the 085 work with 900 megahertz radios only, or does it have 2.4 gigahertz capability?
Sorry, the next question is, does AI work with 900 megahertz radio? So it works with 900 megahertz and cellular communication. So we don't use 2.4 gigahertz. And the reason for that is the higher the frequency, the less the penetration is. So for instance, if you're using DSRC and CV2X, that's 5.9, it doesn't go as far, whereas 900 megahertz can penetrate the leaves of the trees better. So we did some testing, actually Quebec City did some testing of, it was GTT's 900 megahertz system, GTT's 2.4 gigahertz system and our 900 megahertz system, and it was a very treed corridor. And they were getting about 900 to 1,000 feet on the 2.4, but they were getting 3,500 feet on the 900 megahertz. So it just penetrates trees and buildings and everything like that a lot better. And then our backup communications, obviously cellular.
Okay, and then the final question I have here is, could you please elaborate on advanced activation of Preempt? How far ahead from an intersection does the system detect emergency vehicles?
Great question. So it's an unlimited range. If you wanted to put in a preemption call 90 seconds, 120 seconds away, because the controller was really advanced, that could start changing the cycle times. Changing the splits and offsets and keeping it within its cycle time to coordinate with all the other intersections, then we can send it like that. So we've done that in some cities where we're using NTCIP 1211 and shooting that information over with a 90-second ETA and counting that all the way down. But because we're using the cellular modems, we can do an unlimited range away from the signals. So it really comes in really interesting when you've got non-emergency vehicles, because you probably need to do that at round about 30 seconds to 45 seconds, depending on your dwell time and obviously the peg clearance times. But when it comes to transit vehicles, you can really start preparing the traffic controller very far in advance, because you can start putting that information a full cycle in advance. So, and it's all configurable by rules. So all of those rules and everything like that can be done.
All right. Could you explain adaptive preemption and how it works?
Great question. So what we do is, if there's an emergency vehicle approaching a traffic signal and there's a lot of traffic backup, and all of a sudden that emergency vehicle is driving at 45 miles an hour, and then he starts slowing down, and he slows down to 19 miles an hour because there's traffic ahead. What we do is we trigger an early preempt call at that intersection, but not just that intersection, normally the intersection ahead of him as well, so that we can flush out the traffic ahead. And all of these rules are configurable, but what this does is it adapts to the traffic congestion so that if you see the vehicle slowing down, we can actually cause an early preemption and flush out that traffic ahead.
Okay.
I think someone raised their hand.
Yep. I'm going to unmute Ken.
I'm just curious where the rules are. Are there rules at the intersection? Or are you propagating the rules from the cloud reporting system? I'm confused.
Yeah, so all the rules are locally in each individual device. So we have a central system that we configure the rules, but all the rules are locally in the device. So we've got a distributed intelligence system. So it's not like you've got a central computer that's saying, I need preempt here, I need preempt here. Each individual system works as standalone, which is really critical for emergency vehicle preemption, because you've got local intelligence. So if something fails in the central or with another intersection, everything's using its local rules and intelligence to trigger the preempts at those locations.
And then you can change and optimize those and propagate those out. Am I articulating that correctly?
100%. So all of those rules, and that's how Marietta basically improved their response times, is they looked at the intersections and the areas that were causing them troubles where they couldn't get through, and then we optimized the rules for those intersections to get them out a lot better. So yeah, that is actually, Ken, a great point, because one of the things that we do is we have a distributed intelligence preemption system. And what's critical with that is we don't have any one point of failure. Because what I've found is, there are certain other providers there that are doing central-based preemption. And when you do central-based preemption, all you need is the vehicle to change its route or to change, any small little thing, or the computer goes down and now you get zero preemption. The network goes down, you get zero preemption. With ours, even if the cell network went down for some reason, you still got the local radios that are communicating. So having that intelligence in the devices is critical for reliable emergency vehicle preemption. And then we've got one more person there. Jessica Thomas has got his hand up.
I am unmuting you, Thomas. Thomas, are you there? If you don't have mic access, you can also type in your question in the chat box and we can read it for you.
Hi, can you hear me?
Yes, can.
Okay. What if you're coming down the street and all your lights are green and all of a sudden one of those lights turn red and the rest of them are green? Does it mean it's out of sync?
Could be multiple different things. A lot of traffic controllers have got a maximum time that's set into the controller in terms of the maximum phase times. So in other words, if you've got 6 traffic lights and you're talking about actually having emergency vehicle preemption within the city and one of the lights changes to red, it could be that one of them isn't working correctly. But a lot of the times that I've seen that, it's because there's a max time of staying in one phase, and that's causing that controller. So you normally go out and change those maximum times. I don't know how to physically do that, but we can get you connected with one of our engineers that can walk you through that process.
Okay, thanks a lot.
Appreciate it. And also important, what we are doing next week, Thursday, is we're doing a masterclass in emergency vehicle preemption with our systems, where we're going to go through. It's a much longer session. It's not as, me explaining everything. It's me actually going through what's in the devices, how do we wire them up, how do we change configurations in the traffic signal controllers. So going into a lot more detail of the actual devices, how do we set up rules in emergency vehicle preemption? So anyone that's a current customer or distributor has access to that meeting. If you want to have access to that, which is going into a lot more detail, please reach out to us. We can add you to that meeting. Just reach out, and it's going to go into a lot of detail of the ins and outs, how you program rules, what are the best practices, working with a traffic signal controller, what should you change, how to get the spat information from a traffic controller. So the master classes are pretty interesting in looking at the details of everything behind this.
Yep. So if you did not receive an invite to that, but you would like one, please email us at training@appinfoinc.com. So that's training@appinfoinc.com. And then you guys will be receiving a follow-up email with the commercial link that Peter showed and handouts about our units and a brochure on how preemption works. And if you guys need any additional support or have questions or want to connect with one of our business developers in your region, then you can reach out to us as well, and we will help you get connected.
Yeah, please reach out to us, because setting up a one-on-one meeting, we can go through all the individual stuff that you guys have within your system, and we can really talk about how we can optimize this for your situation. So I want to thank everyone. Thank you so much for your time. Really appreciate it. And you guys, I'm sure, are going to receive more information about all of this. So please reach out to us, and thank you very much.